Welcome to homework.
Okay, we are trying to make meta-bromoethylbenzene. Why might this be hard? Before we even get to what the following, possible syntheses are, why might this be hard? Well, that's because we've got a meta relationship between our ethyl and our bromo groups, but both bromo and ethyl are ortho-para directors. Ortho-para director, ortho-para director. So if we install an ethyl first and try to add a bromo, it's not going to add meta. We're going to get bromo, para with some amount of ortho, right? So the deck is kind of stacked against us because of that. And that's going to be why when we look at these syntheses routes, right, the first one is ethyl chloride and AlCl3, followed with bromination, right? That's not going to work, right? Because we're going to add our ethyl group, which is an ortho-para director, right? So we add our ethyl group, and then we're going to add our bromine, either ortho or para. We're not going to add meta. So this first method will not work. Well, what about the second method? In the second method, all we've done is just swap the order of these. We add the bromine first, and then we add the ethyl. Does that help? No, because bromine is also an ortho-para director. Recall, yes, bromine is deactivating overall, right? But because it has lone pairs through resonance, it is donating and therefore is ortho-para director. It's inductively withdrawing and donating through resonance. Okay, so the second option is not going to work either, right? What about option 3? What do we got there? Option 3 is that instead of adding ethyl directly, we're going to add an acid chloride. I guess I could draw that in red, but we're going to add an acid chloride, with AlCl3, right, which would install the following group. Okay. Oops, did that backwards? Yeah. Which would install the following group. Kind of like a methylphenyl ketone is what we'd be making. And then follow that up with zinc amalgam and mercury and HCl. What does that do? Well, it reduces. That's going to reduce the ketone into an alkane. Okay, so now we've gotten, to an ethyl. And then the third step is just we add bromine 2 over iron chloride. Oh, sorry, iron bromide, yeah. Iron bromide. Is that good? No. we went through a long process of just adding an ethyl, which is going to be ortho-para directing, right? This is the same problem as A, the first option. But it does give us a hint about something. If you notice that before we reduced this ketone, you may have noticed that carbonyls are meta-directors. Yeah, and that's through resonance. You can, walk through the resonance form where you put the negative charge in the oxygen. This becomes positive, makes this partial negative, partial positive, partial negative, partial positive, partial negative, partial positive, and there's preferential addition at these partially negative sites because those carbons are what are acting as nucleophiles on these electrophilic bromines, right? That's gonna, right? The more negative this carbon is, the more likely that's the carbon which is going to attack a partially positive bromine. Okay, so hopefully that maybe clears up something, that if we install this ketone, that gives us a perfect opportunity to then install the bromine. Right? Now we get our bromine at the meta position like we wanted. And then, only then, do we want to reduce it with zinc amalgam and mercury and HCl. There we go. Yeah. So this sort of motif, or this idea of adding a carbonyl, adding something that you want at a meta position, and then reducing the carbonyl, pops up again and again and again. And recall, the other useful thing about adding a carbonyl and then reducing it is that it doesn't allow for, like if you wanted to add a T-butyl group, recall that carbocations will, like if you had this, if you're trying to do Friedel-Crafts alkylation, that in fact you get methyl migration and end up with this instead. This instead, and you'd add the wrong product. You'd add, if you're trying to add a T-butyl, you'd end up adding this wonky thing. So yeah, Friedel-Crafts acylation followed by reduction is really handy for various reasons.